morning. Uh, this is I'm Kenneth Chow. We can call me Man Chow or Kenneth Chow. This is my quantum gravity series video 39, and today's topic is to A is a methodology for computing using computer and algorithm the masses of particles, which in my theory is only the Broglie Matter Waves. For unknown particles, that is to say, particles which were not yet discovered, and which are also beyond the existing capability of the Large Hadron Collider. And second topic B is discovery of a new particle near the Planck Scale. There's two topics today. First, I start on A. The methodology for computing using computer and algorithm the masses of particles for unknown particle beyond the present capability of LHC. The present capability of the Large Hadron Collider is a combined energy of 14 tera electron volts, which should say a trillion electron volts. Therefore, the most massive particles discoverable in the LHC, the Large Hadron Collider, is just around 2.492 times 10 to the power minus 23 kilogram. That's just to say, just below 100 times of top quark, and of wavelength, which means the Compton radius. That is to say, the wavelength, the Compton wavelength divided by 2 pi. Hereafter, I will just abbreviate it using CR, Compton radius, of around 1.4101 times 10 to the power minus 20 meters. That is to say, there's a limit on the capability of the Large Hadron Collider. They can't discover any new particle above the weight of 2.492 times 10 to the power minus 23 kilogram, or smaller than the Compton radius of 1.41 times 10 to the power minus 20 meter, unless an upgrade of the LHC's capability, unless it's such an upgrade. Otherwise, it would be impossible to discover any further particles above this mass or smaller than this radius, this Compton radius of wavelength, all the way up to the Planck scale, that is to say the Planck mass and the Planck length. That's 2.1177 times 10 to the power minus 8 kilogram, or 1.616 times 10 to the power minus 35 meter. However, by trials and errors, I noticed that there are certain correlations between the particles below, and which are listed below here. And also here. Which are, I have read out. Firstly, we have the cosmic microwave background, the CMB, the Compton radius of which is 8.373 times 10 to the power minus 4 meter. And if you divide it by this another particle, so actually this wave, actually must be wave, microwave, and then IGM means intergalactic medium, which is also mainly hydrogen gas, and which has also have a quantum radius of 1.640 times 10 to the power minus 7 meters. You use 8.373 the CMB divided by the 1.640 the IGM, the intergalactic medium, and you get this figure 5.1055 times 10 to the power 3. And then this is the means this is a ratio of the mass of the quantum radius, ratio quantum radius. As I classify this column is quantum radius ratio. This another column is the mass ratio. Now we come to the mass ratio. The intergalactic medium, the mass is 2.144 times 10 to the power minus 36, and that's the cosmic microwave background, CMB, is 4.2 times 10 to the power minus 40 kilogram. And you divide it, and then you get it. Also, equal to 1.105 times 10 to the power 3. And another, and the A and then B is another two types of particle. This 21 centimeter hydrogen. You have the 21 centimeter hydrogen, the quantum radius of which is 21 times 10 to the power minus 2 meter. And then the other particle is proton. I choose proton. Its quantum radius is 0.21 times 10 to the power minus 15. And then you divide these two, you get what? You get 1 times 10 to the power 15. But then you also divide the proton mass. It's 1.673 times 10 to the power minus 27 kilogram. And divided by 21 centimeter hydrogen is 1.673 times 10 to the power minus 42 kilogram. Why do we have to reverse the numerator and the denominator? Because the bigger the mass, the smaller the radius, the quantum radius, they are inversely proportional, and the bigger the quantum radius, the smaller the mass. So I have to divide it. Reverse first you have the 21 centimeter and hydrogen divided by the proton, and the second you have the proton divided by the 21 centimeter, and the result is the same. 1 times 10 to the power 15, 1 to the 10 to the power 15. And the third one, I result out this only to show that these particles are correlated. Similarly, we have used an electron neutrino, and then divided by the electron. The radius is 3.62 times 10 to the power minus 13. The quantum radius of the electron neutrino is 0.988 times 10 to the power minus 7. We got 2.558 times 10 to the power 5. And then reverse the denominator and the numerator, because the bigger the mass, the smaller the radius. The smaller the radius, the bigger the mass. And the bigger the quantum radius, the smaller the mass. So I have to divide to reverse the numerator and the denominator. And so we got the same thing, 2.558. I will explain this why they're the same. And similarly, I have the muon neutrino, and then divided by the muon particle, and then similarly we have this E, we have the tau neutrino divided by the tau particle, and then lastly we have got the proton divided by Planck length. This is very special because of the big difference between the two mass, the Planck scale and the proton scale, and of the Planck and the proton quantum radius and Planck length. The Planck quantum radius is Planck length. So I just let you see it because they are all similar. And this is how because to show them that these particles are correlated. Now we got come to the explanation. The explanation for why that all these figures are the same. Whether they divided by the quantum radius of the one, by the quantum radius of the other, and the mass of the one by the mass of the other, they're all the same. In my theory of quantum gravity, that's the Planck black hole theory, which incorporates the Broglie Matter Wave theory and my new hydrogen atom model. There are 10 Planck black hole equations, of which equation 1, equation 2, equation 7, equation 8, equation 9, and equation 10 were entirely originally derived by me. In all the set equations, the terms the mass and the quantum radius are always inversely proportional to each other. That to say, if for example the mass is 100 times bigger, one is 100 times bigger than the other particle, the corresponding quantum radius will be exactly 100 times smaller than the other. That's why you get all this division the same. When you reverse the order of the numerator and the denominator, the same. Yeah. The same. The same. And the same. This means the mass times the corresponding quantum radius always equal to a constant. For example, in equation 1, I have to show you something, otherwise you don't know what meaning by equation 1, equation 2, equation 3. This is equation 1. We have h bar is equal to the mass times the corresponding quantum radius times c is equal to h bar. And then the equation 2, and then you have e squared is equal to 10 to the power 7 times the mass times the corresponding quantum radius times alpha, etc., etc. And 7 and 8. This all divided by the original. In equation 1, mass times the quantum radius is equal to h bar divided by c, which is of course a constant. H bar is a constant, c is a constant, so it must be constant. In equation 2, the mass times quantum radius is equal to e squared divided by 10 to the power 7 times alpha. Alpha means the fine structure constant is a constant. And 10 to the power 7 is a constant. E squared is a constant. So it's a constant. In equation 7, mass times the quantum radius is equal to e squared divided by 4 pi epsilon naught times 10 c squared times alpha. 4 pi epsilon naught is a constant, c squared is a constant, alpha is a constant, so it must be a constant. And equation 8, the mass times the quantum radius is equal to 2e divided by 10 to the power 7 times c squared is also a constant. This rule, I now call it the rule 1. In particularly F, what is F? F means the proton divided by the quantum radius divided by the Planck length, and then the Planck mass divided by the proton mass. This is the F. And then the same, 1.310. 1.310. This one, what was so remarkable about this one? This one is this F shows that the through U1 even holds between the Planck mass and the proton mass, and between the Planck length and the proton quantum radius is particularly remarkable because it demonstrates that even between a particle which is known and discovered long ago, the proton, and a particle which is in my theory as a Broglie Matter Wave at the Planck scale. This rule still dominates. This rule dominates across 19 orders of magnitude. And this incidentally also proves that Planck mass is a real particle. It's up to now we just don't know what Planck mass is, because the Large Hadron Collider can never reach the energy of the Planck mass, so they cannot discover the Planck mass particle. But since it's also correlate in the same way as all the other particles here, which can be discovered in the LHC and the Large Hadron Collider, It's the same. It's the same as the other particles. So it's a real particle. It's real. It is real in the same way as A, B, C, D, and E are real. Now come to rule 2. Rule 1 led me to this idea. If the mass times the corresponding quantum radius is always a constant, then even if the mass and the quantum radius is interchanged, the position interchange numerically, this rule may still hold. This led me to G below. This F, E, A, B, C, D, E, F, G. Now come to G. What is G? It's the mass of a particle not yet discovered or known, but is of 0.2103 times 10 to the power minus 15 kilogram. That is to say, its mass is numerically equal to that of the proton quantum radius. An interchange quantum radius with mass, and then divided by the mass of an electron, is equal to 2.308 times 10 to the power 14. And once again, I reverse the denominator and the numerator. The quantum radius of the particle not yet known, of the same particle not yet known or discovered, of 1.6726 times 10 to the power minus 27. Meter. That should say, if this unknown particle's quantum radius is numerically equal to that of the proton mass, in the interchange the mass with the quantum radius. This rule 2. You can interchange them. It's the same thing has happened as with rule 1. And then I divide this by the quantum radius of the electron, which is 3.862 times 10 to the power minus 13 meter. And the same thing happened as above, as A, B, C, D, E, and F. 2.308 times 10 to the power 14 and 2.308 times 10 to the power 14. So I got this G. How do I get this? I get it by guessing that because the Planck black hole correlates with the proton by mass and quantum radius, so I guess a yet not discovered particle mass 0.2103 times 10 to the power minus 15 kilogram and quantum radius 1.6726 times 10 to the power minus 27 meter. It's near the Planck scale. The Planck scale is 10 to the power minus 8 for mass, 10 to the power minus 35 for quantum radius. So this new undiscovered particle is near the Planck scale. I guess it might correlate with another particle near the proton. So I arbitrarily randomly chose electron, and I get it right by chance. Rules 1 and 2 can be used to compute, not experimentally discover, but to compute. Maybe using a computer with an appropriate algorithm. Some unknown, not yet discovered particles in the range of the energies beyond the capability of the Large Hadron Collider. This might solve the problem due to the limit of maximum capability of the LHC. Although, of course, this computational work might be painstaking. This is a way I suggest this way can use to compute. Actually, after I've written this video, the script of this video, I've tried some others and found that these rules always apply. So you can try at home. And so if you're interested, you can subscribe and like, etc. Okay, bye bye.